Hey, so firstly, thank you everyone for coming to our workshop. Before we begin, this is one of the first attempts we've done for somewhat of a live workshop. So if you all have any feedback about making this better for next year, please, bring that forward towards the end. Our intention here is we're going to have some fun. So don't think of this as a one-way street today. We're going to do a live session. We're going to end up building a single-player and a multiplayer game. Uh, and so for people, those who think that they're not getting anything out of this session, at the very least, we have some amazing swag. So you can always tell your friends who got something out of the session. But with that said, let's get going here. All right, so again, because of the lack of internet and note taken, we don't have this, but people like you who wanted to code, this is essentially the prerequisites. But what can you expect from this workshop? So it's usually this workshop is designed for beginners to amateur game devs. Some people who've dabbled in Unity, Unreal, Godot, any of these game engines. Our intention is to give an overview of multiplayer game development and do some kind of a live code walkthrough. But towards the end, we're going to build two games. We're going to build a single player experience. Think Flappy Bird, but with a spaceship. And then second, for those who've seen Squid Games, who've seen Squid Games, we have a red light, green light kind of a multiplayer experience where me and Animesh will actually play that game. And so that's what you can expect from this workshop. Someone had a question back there. All right, so before we begin, you all should know who you all are hearing these things from. And so I'm Ajinkya, originally a Pune boy, but I've been living in the Bay Area for the last 15, 16 years. I'm ex-Zynga, so worked in the Zynga San Francisco office right from the Farmville days. I accidentally became one of the co-author of the entire Zynga platform. We built it for Farmville, and later it just took over the entire, all the games. Essentially, I use it one way or the other at Zynga. And then I was the CTO of the Farmville mobile franchise, and then the head of engineering for the Words with Friends franchise. And then now, recently, a year ago, I started my own gaming startup, a gaming backend startup called Snapser. And so as part of this workshop, you all are going to see a few elements of Snapser as well. Let me pass on the mic to Animesh to give your intro.
Yeah. Well, that's where I met him. We used to work at Zynga together. But then I went on an indie journey and I became an indie game developer. And now I'm also working with Snapser on building this tool out.
No, the thing is...
Yeah, we're going to fix that. They need to tell me the resolution.
Okay. All right, so what are the tools that we're going to use today? Animesh is going to show a lot of Unity stuff today. We are going to give you all a glimpse into Snapser, the backend infrastructure company we're building. Towards the end, we're going to share a sign-up sheet. It's not an open product yet. It's behind closed doors. But anyone who's interested for our early access sign-up, we would love to kind of give you all early access. All right. So with that said, let's begin the actual workshop. And we thought, the best way to get started is just a quick bird's eye view for as far as, what are the typical gaming architectures or typical type of games that people can build today. And the best way to think about that is these four verticals, so as to speak. So, device-only games. Then there are single-player experiences, but backed by cloud. This is essentially where the rubber meets the road, and you'll have your first interaction with some sort of a backend. And then social. Social gaming is huge in the world. It got picked up in 2010. It's more about, multiple people. Even though it's a hardcore single-user experience, you still have a way to interact with other people and make friends. And last but not least, one of my favorite genres, which is any kind of a real-time multiplayer game, where you're actually, battling or, playing a card game against someone. And so let's look at these architectures for a bit, right? So I call this device-only gaming the best gateway drug. So any of y'all who are thinking about, becoming game devs in the future, it's perfect, right? Just pick up Unity, pick up Unreal, pick up Godot, look at some tutorials on YouTube and get going. These are your device-only games. These games will run only on a particular device. You don't need a server or a backend, and make something fun. So, who remembers Flappy Bird here, right? It's literally a game built by someone over a weekend and took the whole world by storm. Those are the kind of games that we call device-only games. Let's move on to the next, which is essentially where the rubber meets the road for a backend. So these are single-user experiences. Very cool. So yeah, continuing down our journey of just identifying these kind of game categories. So Single users, this is where multi-device support comes into play. Because data is backed by a server, a user can pick up their iPhone, start playing a game, then pick up their other iPhone or an Android device, log in, and then start playing the same game again. And then it's perfect for new developers. I still think this is a genre that new game developers should definitely consider. And there are plenty of tools to make your life easy. Obviously, Snapser is one which you all will see, but there's PlayFab, there's Firebase, which obviously you all have heard of. And so that's essentially what single-player experiences are. Moving on to social, that's when we realized as game developers, our job is to try to keep users into our game, which means we need to have more engaging features. And that also means that human psychology tells us that more of your friends or social elements introduced into a game, the longer a person stays in a game. And so this is where, your backend, you start thinking about gamification features, be it the quest achievements, leaderboards to get a sense of competition, make guilds, for example, in Clash of Clans, etc. And so the typical examples of these games are, Farmville, Candy Crush, two of the biggest franchises in social gaming. Latency is not really a major factor here. Usually, these type of games, a client code base is essentially just firing a call and forgetting about it. They don't really care how long it takes. And so, that's not really a requirement for usually these genre of games. But exactly the opposite are these multiplayer real-time games. Think Clash Royale, one of my favorite games I still played every day for the last, 8, 9, 10 years at this point. They have an element of social features, but they have an element of a real-time gameplay where 2 people, 3 people, if it's a tank battle of 15 versus 15 people are playing these games. Latency is a major factor as far as the genre of these games are concerned. Because you can imagine if 2 people have variable latency, the experience is going to be really, really bad, and you're going to see churn in your users dropping off from your games. Examples again, I just mentioned Clash Royale and poker. And so in this workshop, which now is not really a workshop, it's more of a walkthrough, you're going to see a journey of, we're going to create a single user experience, and then we're going to then use Snapser again to just unlock real-time multiplayer and then build Squid Games, red light, green light kind of a game in Unity. And so y'all will see the full spectrum as part of the next hour or so. So we thought before actually starting a live coding session, we should talk about the fundamental building block of any multiplayer networking backend, which is authentication. And so any game studio here, any backend engineers here who've thought about building their own auth, it always seems simple at the start. It always is complex. But the good news is there are plenty of people who've solved that problem. So you don't necessarily have to build it from the ground up, but I just want to make sure you all understand it's definitely harder than it seems. But this is fundamentally where you secure your gameplay. What does that mean? Every user playing your game essentially can be associated with an identifier. And authentication makes that happen. And then every other call going to the server or the backend is essentially going to be fired with something like a JWT token. So we'll talk about authorization in a bit. But there's also an element of third-party logins. Show of hands, people who know or remember the crazy Facebook gaming phase where people were just going crazy, right? So the whole point there was that add a Facebook connect to your login. And then you can actually extract and bring all your friends onto your game. And then that increased the retention, etc. And so usually a lot of auth providers, be it if you're making an app or a game, you will have some kind of a social connect. In fact, if you're making a mobile game, I think Apple and Google enforce you to have sign-in with Apple and Google nowadays. And it also helps with game state recovery, right? So imagine you've built a game and a user has really spent, months, playing your game. And then suddenly, if that game state vanishes, you have a really, really upset user. And so I think authentication is very, very critical and is the fundamental building block for game making. So for those who are interested in actually building authentication from the ground up on the back end, I would love to geek out with you folks, but the best way to think about that, in my opinion, is a keychain. So if you look at the top section right here, this is where a user on any device is essentially trying to do a login with the backend, and think of it as a keychain, and your authentication service or a backend associates that player ID and attaches that to the keychain. Next comes in the case where Actually, let's talk about the typical mobile flow, right? So on a mobile game, you do not want to add friction for your users, and you want to get those people just start playing their game. And so a lot of people use anonymous login or device login, something that Animesh is going to use during the workshop. So that's where the user got player ID number 123. But you know what? A PM or a product manager in the game studio comes to you and says, you know what, now I need to know who the user is. We have no idea who the user is, and I want to get their email so that maybe we can reach out to them via a campaign or send them an email later on about our game. And so that's when a product manager essentially tells you, hey, let's please put a wall for them to email connect. And so what happens behind the scene is the minute you tell your auth service that you want to email connect, you fire off an associate call instead of a login call. And that's where now your email is connected to the same keychain. That's how your authentication backend can still know whichever way you're coming, it's associating you with the same player ID, which is 123. Moving on to the typical, web or mobile example, you want to add Facebook Connect, it exactly works the same way. You now add a third ring to your keychain, and that's how I personally think about authentication. Remember I said this is the fundamental way you secure a game, and this is a perfect example. So here's a user, let's say me, and my email is aj@gmail.com, and I associate it, and here's how my keychain looks like. There's this hacker who's come in, and in their own keychain, they have their own anonymous login, that's PID456, and they did email auth. But later, they actually somehow got access to my Facebook account. Our authentication will still not allow that because it identifies there's already someone with Facebook ID 123 associated. And that's how you can actually protect people. Even if I will lose my Facebook account, they might hack me on Facebook, but the game still remains secure because the auth service has identified there is already someone with the same identifier here. I know this can be a little overwhelming, but I'll just pause right here if anyone has any questions. Like I said, it's an interactive session. Would love to answer any questions people have here. Otherwise, we'll move on. No? Cool. All right. Let's talk about authorization, right? So authentication and authorization kind of go hand in hand, and people sometimes use it interchangeably, but I personally obviously want to separate it out very clearly here, which is authorization is all about once you have your authentication and your identity, you're now using that to authorize with your backend and confirm you have permissions to do an activity on the backend. And so here, I've given a Farmville example right here. I'm a user in this blue jacket right here, and I want to see my farm. And so I fire a call to my storage service saying, hey, storage service, here's the token that the authentication backend gave me, and I'm hitting this particular URL. And I get that information, and that is what renders my farm in Farmville on mobile or web. Now this user, user number 2, let's say that's Animesh, that's his identifier, and he has his own farm right here. Now, if I try to be cheeky, I open up Postman, one of our favorite tools coming out of India, and I just kind of fire an API call saying, I want to actually view Animesh's blob so that maybe I can hack into it. The storage service is not going to allow that. Why? Because it knows that I'm trying to access someone else's identity. The token is what is going to identify me as 1, 2, 3, 4, but I'm trying to access 5, 6, 7, 8's data. And so the storage service is going to say no. Now, one may ask, does this happen implicitly? No. The backend engineer who wrote the storage service has made that decision. So it's not something that just comes out of the box. You guys and gals have to make that decision if you all are creating that. But this is a perfect way to think about authorization, in my opinion. And lastly, yes, auth and authorization is the first fundamental building block, but this is a close second in my opinion and neglected by a lot of early game devs. Some people call it game config, some people call it remote config, doesn't matter. The fundamental principle is simple. You want to hit a server endpoint and get a particular config from your server to power your game or power your app, right? So it's usually an afterthought, but it's important, and especially for games who enter live ops, right? If you're just creating a game and sending it out there on a console, this part doesn't really matter. It is really important though for anyone considering a live ops game, a typical mobile game where you want to keep shipping new features. Why? Because it gives you the power to make remote changes. And I'll give you a classic example. every game studio, whenever they're working on a new feature, they suddenly are releasing like an events mechanism or an achievements mechanism, engineers will try to wrap it in what we call like a kill switch. Why? Because it is totally possible I release something on the App Store and I have an update on my client app and there are bugs. Well, we engineers always will have bugs in our code. But then what happens is, even if you fix it immediately, Apple takes a couple days to say yes to your app. Google is probably better. And so now what do? So that is one reason why something like a remote config, in our opinion, should be a fundamental building block, because you can then go to your settings on your remote config and say, just kill this particular feature. And now you've suddenly stopped any of the issues that are happening within your game. It's also great for gradually releasing features. So it's not just about the kill switch. You folks can figure out, I want to actually release this only to 1% of the audience. And that's exactly how Zynga operates, by the way. Any new game feature we do, apart from the A/B testing that Zynga was always famous for, it used to always ramp features very, very slowly. Ramp it to 1%, confirm your tier 0 metrics look good, then keep ramping further. And so remote config really helps with that. And this is how a typical game start flow, in our opinion, should look like, right? So when anyone picks up your device, which is your client code now firing, it should essentially fire a validate call, confirm your token is still valid, right? That's always important. You go to your auth provider, confirm, hey, here's the token I had. Is it still valid? Okay, it's still valid. Let's initiate a game initialization, which is I hit remote config, get usually a JSON kind of a list or a blob, and then I power my game, and then you start your flow. So that's a very typical thing you will see in serious games today. And then, with that said, here is the exciting part of, hopefully you will find this exciting, of our workshop. So Animesh, on to you.
All right, yeah, so the more interactive part of this workshop. Just show of hands, I need to first understand how many of you guys are software engineers? Oh wow, it's almost the whole room. Game engineers? And Unity? Okay, that's pretty good. That's nice. All right, so let's first start here. All right, so this is our Flappy Bird kind of game that we did in maybe like a week. We hacked it up in a week. So I'll just play this, and you can probably relate back to what Ajinkya was saying in his presentation earlier. So this is like a single device experience where I can press space, I can move, I can die, but it's done. So now there's not a lot of feedback from the game. There is not a lot of security, as in like you just have the singular experience, and that's about it. Now, if we do the login, doesn't really do anything. Why? Because we haven't really hooked up the front end of the game to the back end. So now what we'll do is we'll go to Snapser, and by the way, this is not specifically Snapser. You can have PlayFab, you can have any other service, you can build your own service, and that could be the connection. But for this experiment, we'll just do Snapser. And we've already created a company called IGDC specifically for this. So now what we'll do is we will create a new game called Interstellar, and let's start. We will create a new dev environment. Let's call it demo. Then we'll go ahead, and here is where we need to make selections of what kind of services do we want in our game. We definitely want authentication. Let's start with that right now. But as you can see, there are a bunch: experiments, relay, stats. So you can basically choose what you want. You don't need to bring in everything that is related to the backend. You can just pick whatever is important to you. In the current case, authentication is important, so we'll just continue with that. We'll go, we'll snap it, and this is it. Like, this is on the backend, on the backend, your game's backend is getting spun up as we speak.
I'll just add one thing real quick. Show of hands, anyone here who's used PlayFab, Firebase, any of these things, right? Okay, cool. So I just want to point out one thing. One fundamental difference the way we're building Snapser, and sorry to kind of, praise Snapser here a little bit. That's not the intention. But unlike a PlayFab or a Firebase where it's a black box and you all use it and all their customers use the same, here every dev environment we're creating is its own PlayFab, its own Unity web services. And that's the power of Snapser, where you're essentially getting that entire thing at your fingertips right here. So what Animesh built right now is a full-on Kubernetes cluster. Again, people have heard of Kubernetes. It's one of the highly used environments in production today. It requires a lot of infrastructure experts, but we've built it with like a few button clicks.
Yeah, exactly. And this is it. This is your URL to your backend essentially, and you can make authentication calls from here. You can, obviously you need a way to access all of this from the front end. So we have a bunch of front end client SDKs that you can access. For us, we are going to need Unity C#. So I'm going to start generating, and then while this downloads, what we also need to do is we need to set up authentication so that from the client we can make certain access points, right? So for this experiment, again, we are just going to do a simple authentication, which is just anonymous. You don't need like any fancy Facebook or Google, but although that does add more security, right? But here you can just keep adding as many as you want, whatever is convenient for your game. For now, we're going to do anonymous login. And that's it. This is basically like on the back end. The backend is ready to now accept anonymous logins. While we did that, our SDK is also ready. Yeah. So let's extract this. This one. And here basically like our SDK is completely ready. So we will just take this, go into our Snapser environment, and then just add this in, and that's it. And then Unity will bring in the SDK on the front end. Now basically from your C# code you can access the SDK portion that we downloaded. In our case, it was authentication. But as we go along, we'll do leaderboards, we'll do profiles, we'll do stats. So you can have all the access that you want from one place. So I'll just quickly show you the auth service API, which kind of looks like just a bunch of code, right? But let's look for. Yep, so anonymous login. So this is the call that you would want to make, and then as you'll go along down the rabbit hole, like what do you need to create, like the requests and everything, but that's for another time. So what we need to do is now around this SDK, it would be ideal if we create a wrapper around this SDK, which is more accessible for your game. So I've created the skeleton already. So if you can see, like there is already a call here, which is again async. Like you can choose, like it can be async or not. It's up to you, but most games nowadays will do asynchronous calls because you don't want to hold up the gaming thread and create like jerks in your gaming experience. So now let's integrate the auth service that we just brought in. So when the Snapser manager gets created, we will also create our auth service API, because the auth service is more like, think of it like all the other services are an arcade with no door, and auth service is the door to get into the arcade to go access all the other arcade games that you're gonna have. And then this one needs the cluster URL. Cluster URL is what we had here. So we'll copy that. We will add that to our game constants. So it's in a central place and you only need to change it in one place. This is it. This is just what we created right now. And that's it. This basically creates your auth service. Now let's go back to Unity. is go to the HUD, which is just the UI portion of it. And then on the login screen, the login button, let's make sure this is calling on login press. So let's open this up. So as you can see right now, it doesn't do anything. It doesn't, like, it's just blank in there, right? Like, so as soon as you click the button, what we want to do is fire off the anonymous login call. So let's say instance, and then what does this need? Right now we will not worry about the callback. And then for the username, let's add the best snapship player, which is me, because I made the game. All right, now let's see what happens.
One thing I want to point out real quick in like an actual game, a lot of games use the device identifier, right? So you'll get a device identifier from Google or Apple, and rather than putting the best snapship player, although that's debatable, I don't know, you will probably plug in the device identifier, and so nothing's hard coded, and every user gets their own space on the backend.
Yeah. So this should go here, right? So what I will do is just uncomment all of that, and then we'll just walk through this. Never mind. So now the UI, you click the button will go to Snapser Manager. Now the Snapser Manager needs to access the SDK and actually make that call. So auth service API dot anonymous login async, and then this needs a new request body, so you can just create one inline. Then this needs create a user. So if a user is not created with this username specifically, the backend just knows, all right, just go ahead and create it. And then we have already passed in the username, so then we just access that. And that's it. And then this should do it. But again, this is an async call, and also we need to collect the response back from when the server sends information back, right? So then we will do anonymous login response, and then await. So this will basically fill in the response here. So now once we do this, let's say, let's just put a debug log here. If response is not bad, then just say anon login successful, right? So now let's see what happens when we actually try to log in through the game. Nice. That's because we probably didn't create. Right, exactly.
Sometimes the next part of the sessions are going to be pretty quick, so don't worry. We wanted to take some time showing you all auth a little deeply, and then we'll do a much quicker code walkthrough for the remainder of the whole workshop. And then towards the end, the people want to hang back and just have a chat, no more, we'll absolutely do that. So we'll focus on that just because we actually couldn't pull off a live workshop today.
So that was happening because there was no way to access the Snapser manager. So once the Snapser manager is created, you create the singleton for it, and I think now it should work. There we go. So it did make that call, and we got the anonymous login successful message. But again, even this is not like very useful. Like, what do we do? Okay, anonymous login is successful, but how does this help other game services open up? So what we want to do is through the response, what we also get is a user ID, the user information. So we'll get the user ID back. We will get a session token back. So we would want to store that somewhere so that we can access that later. So let's just create some private fields which only the Snapser manager can access. String. What? Didn't I just create it? Oh, I just created them in the wrong place. Never mind. So user and then ID. So we'll store that. Session token, we'll store that because we're going to need that later on as we integrate all the other services. Right? So now we got this. Now this is again well and good, but we still don't know how this will impact the UI, right? Like that's where we actually want to show information which is actually there. So I've already created this callback. So instead of passing null here, we will pass in this callback. So when the call is successful, I'll show you in the Snapser manager. So when the call is successful, if the response is not null, what we can do is we can just fire off this callback. And then this is going to be snap service. This is true. Okay, whatever message you want to send. And then the response is going to be the actual data. So even the UI can do certain things about it, right? So in this case, all I'm doing is just I'm going to, as soon as the login is successful, I'm going to just hide that UI. But as later on you see, like in this demo, as we progress, you will see like a lot more happens. Like you can fire off events and ask all the other services to then start making their calls. So you can see leaderboards, you can see storage, you can change the color of your spaceship, and that all of that gets stored. So this is sort of like just the entryway that we are creating for our game. There we go. So as soon as we did the login button went away. So now we have all the information ready to then take this and like make this more interesting, make this more interactive, make this more social. And that we'll see as we hand it over and learn about the game services.
Thank you, Animesh. Obviously, I admire people who can live code. Things go wrong more often, but that was nice. All right, so game services. So remember I said, in that third category of game making, it's all about gamification. So, you probably heard multiplayer services on PlayFab, Firebase, etc. And so we've picked 3 right now, which we're going to integrate and do a code walkthrough for. So a profile, every game, there is some sort of a user profile information you want to show about a user. For example, in Words with Friends, if I go and visit someone, I want to look at their profile and see who I'm playing against. Statistics is a snap that Snapser supports where you essentially want to start recording things at a per user level. So, for our Flappy Bird game, you want to record the distance that has been traveled or the number of wins that have happened, etc. And then leaderboards is obviously something which adds a little bit of a spice and competition to a game. And so, it's basically, it's unlocking gamification. And one thing you have to really know is the minute you're thinking about making a social game, scaling and the importance of a backend that can scale becomes really important, because you never know when a game can go viral. And it's very easy to write bad backend code where the backend topples over the minute you reach scale. Typically, game services, as you saw with Animesh, are integrated in either direct API calls, like even on Snapser, you could have chosen not to use the SDK and just fired off API calls. But more often than not, even if you're building it in-house, your backend team will come up with an SDK that your client team can integrate and start talking to your own backend. And some have settings and configuration, which is nothing but what Animesh did by adding the anonymous login. So a typical flow is seen right here. That's the auth snap, which we just snapped in, is going to be used literally everywhere, right? So once you have the token and the identifier, which Animesh showed you all, you're going to essentially start using that information in different calls. So in the first call, which is about, let's say I want to get my own profile, I want to see my own profile, you're passing the token with that call, but you're also passing your identifier so that the profile backend service knows who am I supposed to send the information about. Next, for example, statistics. You've picked a particular statistic and you're just firing off calls as your game is progressing. And then for a leaderboard UI, you're essentially talking to your leaderboard backend service to be like, hey, I want to see the top ranks, or I want to show a UI of people around me. And that's essentially that call. But everywhere, the least common denominator will always be the authorization that we created in the first step. And so, Animesh, back to you for the Snapser setup.
So I also want to ask, how easy or difficult, well, I guess, how easy was it to follow the code along? Like, was it like difficult to wrap around like the language, or was it easy? So that I can switch it up a little bit. Easy, cool. So now that we've done the auth bit, now we can go there, go on our snap end and add more services. So what we're going to add now is leaderboards, profiles, and then let's do stats. Continue the same process and then snap it. And again, this is going to generate a new SDK that you want to integrate. I have already done that. So I'm just going to switch to the main branch and just show you guys how the game is going to look at the end, right? Like with everything integrated. And actually, we'll just, anybody who wants to play the game and set like a high score on the leaderboards, they're welcome to come and do that. So let's wait for Unity to get all the changes in. Now the serialization happens in the SDK itself. So from the SDK, you're going to get an object with a response back, which is going to be an array of leaderboards, profile name, and all of that.
Yeah, so one more thing. So in the sense of like, is it providing just like a inbuilt function that you can just pass in the data that you want and it's going to take it all, store it in your profile as well? Yes. Or you need to write your own classes for that?
Let me show you. I think it'll be easier if I just
It's the former. So like that's what we've done as heavy lifting. You literally just, actually Animesh, can you do this? Can I use your thing 1 sec? So let me, Mac. No, not Mac.
Windows.
Are you on Chrome?
Yeah.
Okay. So, okay, it seems like our cluster is live. What I wanted to quickly show you to answer your question is, if you go to the API Explorer, here, let's say your question was on profiles. So when you look at the get user profile, you actually see the exact methods also here that you can call on your SDK. And so essentially you'll call like get profile and you'll pass in the information right here. So your API Explorer will show you exactly how even the SDK behaves, but you will never have to write serialization or netcode. That is all part of the SDK.
Right. And then on the code side, I'll just explain how that's going to look on the Snapser manager, which this one I've already written. So we did the authentication bit, right? Similarly, we'll do profile. So when, let's say we do a get user profile, when the response is correct, when it comes back, it's going to form a Snapser profile. You're going to get that object, and you can use that and then do whatever you need with your UI. And that's, once I run the demo, you'll see how it all kind of works out.
Great.
Time the expiry expires.
Yeah, great. A great question. Yes. So for security, every good backend which has authentication will have like auto expiry. And nowadays, people used to put in 30-day expiry. Now they're coming down to like 7 days. Anyways, yeah. But to answer your point, I think the SDK automatically does not renew the token for your behalf, but it has an endpoint for you to trigger to renew the token. So usually what Flow game studios follow is the minute a warm launch happens, warm launch is just, or even a cold launch, it first calls the validate call to confirm whether the token is active or not. And if it's not, it then pushes the user back to the login screen. Unless you are a full-on anonymous game, you have only anonymous login, then it doesn't matter. But otherwise, you'll push the user back to the login screen, and that is why you have to log in again. So what we've done is we've given API SDKs, but we're not opinionated about forcing you to use it in a particular way.
One more thing, can we control the expiry timer?
Not yet, but that's something we can absolutely add as an update to the auth snap. Yeah.
So I think this is more of a infra question
Yeah.
from your side. So
Yeah.
hi. So I was wondering, and maybe it's a gaming standard because I come from more of a software space. So like, why do you build the SDK as opposed to just having a single SDK which has everything in it?
Great
instead?
question. Great question. So here's our fundamental belief, and yes, it is particular to. Well, actually, it's not particular to gaming, but I'll tell you where it becomes important. So memory is absolutely important in gaming, right? And so if anywhere where you can squeeze memory, I think you have higher chance of putting in more assets and more content for a game. Especially for low-end Android devices, your apps will get killed. And so the rationale that we had was that we fundamentally do not like this one SDK approach where SDK hai and just use it. What you're actually getting when Animesh downloads this SDK is only the things that you've snapped together. So Snapser actually builds a custom SDK for you at runtime. And so your memory footprint remains small. You only have the code that you need so far that you've told us. But nothing stopping you from adding new things, and the SDK will keep adding new modules for your download. And so that's a design decision we took because we care about game making and memory. There's nothing against people who have who build single SDKs.
Can I ask one more?
Yeah, absolutely. More the merrier.
And another thing regarding, because I was thinking about the authorization as well, and
Yeah.
I saw JWT tokens.
Yeah.
And again, like, don't know the gaming space as much, but like, why not use OAuth over there? Is that not like a...
No, good question. I think like the way we think about, so your question is in particular about Snapser. Snapser, we're thinking about everything being a Lego building block. And so we've taken JWT as the foundational building block, but we are working on something called as bring your own auth, where now you can like snap anything and you will be then able to use whatever you want. And it becomes a choice that users make rather than everything being very opinionated. And that's the direction we're going with.
Oh, got it. I just wanted to know if it's like there's an advantage there or something. So this is more of an opinion.
Yeah, we have this as the base. I think it serves a big cohort anyways, and for anyone who wants something special, we're going to allow that to be plugged in.
To add to your the first question, just to add to AJ's answer, so as a client guy, if I only want authorization and leaderboards, I don't want to be bogged down by like the whole library coming into my space, right? It bubbles up the game space. If I'm doing mobile, then it becomes even more critical to keep the app size as low as possible. And also just the complexity, like I just know what I'm getting, and it's sort of like what he said, just the Lego building blocks, and it just resonates really well with, I think, client people, client game developers specifically.
Got it. Thanks a lot.
Yep.
Let's just say that I get the token.
Yeah.
It's being like saved in the memory, like in the cache, right?
Yep.
So if a hacker wants, he can just get the token, and then when he gets into the like next time, let's say there is a 7-day expiry.
Yep.
I make it. So before the 7-day, can I, as a hacker, just take the token from the cache and then like remake all of the data to like get in? So like, is there like some security against that?
Yeah, great question. So Just to repeat his question, you're also talking about bad actors, not just hackers, right? Like first, fundamentally, like if someone gets your token, that itself is a big time problem. And so let it be on a cache or let it be there's a man in the middle who's taking it. But for that principle, everything that we do is TLS based. And so there's end-to-end encryption to make sure that doesn't happen. But to answer your question, I think most of even the social and the hyper casual games that are built today, they rely on the principle that the token is really important and closer to the user. But the minute that is compromised, yes, a hacker can go and completely change my farm, sell my goods, and that is absolutely possible. Now there are ways to again fix it. I think security in itself is like another hour conversation we can have about it. But I think usually the fundamental thing that people think about is, yes, let's keep the token as secure as possible, but if it's compromised, it's going to have a big problem. But that is where authorization comes into play, right? So I can use your token, but I can make a change only to that location. I cannot now use that token and impact someone else. I still have to like go and find other people's tokens. And so that is why designing a great authorization scheme for any backend game makers here is very important. So think about the authorization, think about your resource access really, really carefully. And that's one way to avoid it. So at least even if something bad happens, it's limited to a smaller cohort. And it's not kind of percolating anywhere else.
Just one more question.
Yeah.
That, like, on the same note, let's say if someone had like a server authorization, like server-based, an esport game kind of thing. So let's say I got a token, and I go into the I could get the access to a server.
Yep.
Okay. So at least I'm guessing that it's safe on that side, right? The main server side, right?
Yes. Yep.
Yeah. So there is no issue from that point. Right?
Exactly. Yep.
Okay.
Now, I mean, see, bad actors can be anywhere, right? Like you can have a token and you can you can essentially then write a script which is like DDoSing someone's server. Sure, like you can do that to Facebook today or Instagram and whatnot. But that's where I think infrastructure, SecOps people come in. They'll add DDoS protection layers onto your gateway, etc. So obviously at Snapster we've done the same. But there's always a potential that there'll be bad actors within the system. Like they're not hacking someone else, but they are bad actors doing it for their own player ID. By the way, like we on Zynga Poker used to get that a lot. Like people used to actually, it's funny because imagine you're playing a poker game and the minute a big pot has come in, they used to DDoS the remaining 4 people in the poker space. And so they get out and now you get the chips. And so yeah, there are actors within the system and try to do that. And it was a tough time where we had to figure out different ways to make that go away.
So any more questions before we move on?
Yep.
Out of all the auth providers or authentication types, I didn't see OTP. Is there any reason?
So yeah, email is OTP actually. So what we've done is, unless you meant phone auth, over the phone. So yeah, we're adding connectors every couple weeks. So we just prioritize things based on our game studios that we're working with. No one at the moment wants phone auth, which is why we've not prioritized it. As you can see, like the actual, like what we're showing you of Snapster is like hardly the entire thing. It's very small, so our breadth is pretty large, but we keep adding more connectors and that's how we're building it.
And since in the gaming context, does it include that Google Play Games login?
It does. There is an Android login, Google login right here. Yeah.
Also, phone OTP authentication on phone for games doesn't really make sense because you would do Facebook, Google, Apple, all of that for the social elements of it as well. But I think email OTP kind of works the same way. So it's just a matter of preference. But if, say tomorrow in India, I think in India, like OTP usage is the highest. So if there is like a game story that comes and like, hey, we need mobile OTP no matter what, I think it's a very easy ad.
And I mean, again, I think not to speak about the past experiences, but like, yes, at Zynga, we made a choice. We could have gone even phone auth and email auth. I think we chose email auth, looking at our audience. So it just depends. I think, in India, there is a lot of phone auth, but it's also a very expensive proposition, right? Like sending SMS costs money. And so email is what people generally prefer. But if there's a particular use case for phone auth, obviously it's not difficult to add at all. It's just expensive.
Okay, so let's move on. So now that we've added all these game services, we similarly how we set up authentication and we created the anonymous plug on the backend. We also would want to tell the backend and so client, so there is some sort of an understanding between both of them, like what are we talking about. So we will create a leaderboard. I have this key here already, so I'm just gonna copy that so there are no mistakes. Say snapship leaderboard. This is going to be maximum, so it's going to count the maximum score in one single run that happens. Descending external, and we can start the time, which can be now. So this leaderboard will be active from this point. So let's save that. So we've created the leaderboard. We also want to do profiles, similarly how we did leaderboards as well. So here we want to store gamer tags for specific people who choose to. Like it's not even necessary to have like a profile, but you know that's like that's where like the social element of games kind of comes in. For stats, what was it? Lifetime distance, distance traveled.
Who've used PlayFab, Firebase, etc. This seems obvious, but there were a few people who've never used those tools. So just wanted to make it even absolutely crystal clear, right? Like if whichever backend service provider, or even if you're writing it on your own, the way an engineer will write it is they will always keep space for dynamic configuration. So leaderboard, you shouldn't hard code the leaderboard if you're building a backend service. You should build it in a way where you'll take input from a game designer or input from your product managers, and then allow them to build the way that they want, and the leaderboard service should then adapt accordingly. And so this is a perfect example for those who are new to game making. This is how usually backend services are written. They'll always have an admin tool settings component, and then the underlying actual backend code reacts to it.
So our game has a leaderboard, which is the highest distance traveled in one session. And then there is a statistics for each player of their lifetime distance traveled. So if they keep on playing that, it calculates, it basically just is a counter of how much distance they've traveled. So which is why the type here is different. Like for stats, this is counter. And then for leaderboards, we had a maximum. I think it's hidden now, but expand. Yeah, there you go. So here it's maximum. So that's the difference. So you can choose multiple leaderboards. You can choose multiple stats. You can basically do whatever you want. And then we'll also create a storage blob while we're at it. I think this is just color. So very easy. Yeah. And then, yeah, you can control the access level of it. So you can have it protected. So the user who owns the blob can modify it, but anybody else can access it.
Can I interject here? So there was a question about authorization, and this actually is a very, very good example of that, right? So what we have is like 3 levels of protection. There's private, protected, and public. What does that mean? So I'll give you guys an example of, let's say, Farmville, and I think some of you have at least played it in the past. And so I could visit someone's farm, right? Now just think about it. How does that work? I am using my token, but I'm saying, hey, I want your farm. And your farm's blob comes in, and then I render it. The way to do that is with protected. What that means is I can get someone's blob to display it, but I will never be able to modify it. That's why the protected authorization is here. And again, this is a design choice which was done by our engineer who wrote the storage service. It's completely up to you folks to come up with your own paradigm if you all are writing that. But this is a really, really good example of the authorization aspect that we were talking about earlier.
So let's save that. So now all the new game services that we integrated have been hooked up on the back end. So now let's see how it reacts on the front end. Let me get that. So with the new ones, we'll download the SDK again. Any questions in the meantime, this downloads? So it's this one. Let's just take this and then put this in API here. Replace all of them. All right, now let's see if this works. Best part is even I don't know if this is going to work. There we go. Right, so just from the auth, now we have a stat here, which is all time distance, which is this is the current run, so it's going to calculate whatever your current run is and then add that to the leaderboard. This is the storage blob, so if you change colors, this is going to store it. And then you can add your own gamer tag here. All right. I will go back to being the best snapship if I can type properly. Somehow it broke, but anyways, point is, it kind of works now. So now when I do my run, so it added my score to the leaderboard. It also calculated my lifetime distance. So now just to prove that, I will do one more quick run, and then it added the 17 of this run, and then my all-time distance gets calculated. So this is how like everything kind of just works like a snap. So I can choose not to have a leaderboard, I can choose not to have profiles, I can choose not to have stats, but it's just whatever you pick and choose, and that's the idea of Snapser. If anybody wants to come and try and play this, you're more than welcome to. Nope. And then, so I guess I can move on to a break.
So since we were originally thinking of doing like a full-on live workshop, which didn't happen, we're at our 1 hour mark, and now is a really exciting section, which we're actually going to now build a multiplayer real-time game using Snapser and Animesh's game. So show of hands for people who want to just take a 5-minute break, or should we just proceed and then let's do the whole thing, and then we'll leave aside time for people who want to hang back and just talk to us, etc. Do people want a 5-minute break, or should we keep going? Keep going? Okay, let's do that. Okay. Oh, sorry. No, it's fine. I'll just do it from there. Okay. So multiplayer real-time architectures, and this is pretty interesting. And again, I think we all of these topics that you can like spend hours talking to people and gurus. We've tried to just bring it as a summary right here. And so the two ways of doing multiplayer real-time gaming is obviously peer-to-peer. You all have heard that term before, or then server-based. And then peer-to-peer is essentially you don't really incur too many server costs, because if it's a live component, you're essentially talking device to device via the internet, yes, but you're not really incurring any kind of server cost there. The host obviously has an advantage, because one of them becomes a host, the other one is sitting somewhere in the world, and so the latency for the other person is obviously worse than you. It is vulnerable to cheating, because essentially what is happening is you're making a host on a device and there's no server to validate any of the things that are happening. And here's the more important thing. So if you all go and talk to any of the netcode experts in the world, go and talk to the SnapNet guys, go and talk to the Photon people. The problem with peer-to-peer really is not really the fundamental theory of peer-to-peer. It is The problem is that the internet, the way internet exists today, is not conducive for peer-to-peer. Our whole point, the way we as humans have laid our internet lines, every device's job is to quickly go to the ISP provider, very quickly. And from there, it goes to other things. So you two could be sitting here playing a game peer-to-peer. You all are still going quicker to the ISP. And so that is one reason why I think a lot of netcode people do not necessarily prefer a peer-to-peer. They'll probably go for a server-based model. And so let's talk about the server-based model. The minute a server comes in, obviously, there's protection against cheating. Again, it's not compulsory, but you now have an angle where you can put in your code, validate things that are happening. Oh, you can. Again, you absolutely can. I think it was more of a statement for, in general, I think internet is more better for reaching a server today the way it's designed. But if people want a hybrid approach, totally. And there are a lot of games which are built peer-to-peer, by the way. There's nothing wrong with it. Everything has its pros and cons because you'll keep a server cost way lower if it's peer-to-peer, for example. Next is scalable to support user growth. So anyone here, who's been in the gaming business, kind of scaling these real-time game servers is a challenge. It's not easy, right? That's where actually you need a really good experts to do so. Especially as the concurrents blow up. It's not even about the number of users using it in a day. It's about how many people are connected to me right now. And that's something you need to think about. But the two categories, the way I've, in my head at least, kind of thought about real-time architectures is like a relay server-based model or a game fleet or a game server-based model. And so let's look at those. So this is just a quick short illustration of how peer-to-peer will work. Notice now that the minute we're talking about real-time multiplayer games, matchmaking suddenly becomes extremely important. And talk to any game designer out here, one of the biggest challenges always in a real-time game will be the matchmaking has to be right. Because otherwise, if it's incorrect, you will see a big-time drop-off. And so that's why you have your matchmaking thing right there. And what is happening here is both me and Animesh are essentially going to our matchmaking provider saying, let's find a match. And then after the match comes in, we're essentially going to use some kind of a software technology to run a peer-to-peer game. Our demo is not this. Our demo is going to be more on the latter two. So let's move on to how does a relay server-based model works. And if you, again, the same first two things happening, both of us are always hitting matchmaking to tell us, hey, please find someone who's appropriate to play against me. But then check this out. That's where a relay server comes into play. A relay server essentially can pipe packets between two people, n people for that matter. It doesn't have to be two. It can be a 15v15 battler, 1v1 battler, does not matter. And the relay server, you can think of it as an ephemeral thing that comes up, a match is created, people play. When the match is done, it breaks it down, right? So it's not something that is persistent. It can come up and down in terms of the matches. And so a lot of people use this model. And then if people are using complex, games, and if you're using on the Unreal architecture, which a lot of people have a client and server architecture in Unreal, they use game fleets. And Agonis is, again, a really amazing tool that Google created, and it's open source now, that a lot of, not just Snapser, but a lot of competitors in this space use it for their fleets. And so what you'll find here is, you'll hit matchmaking. Matchmaking will essentially tell the fleet saying, hey, please spin up a server. There's a match that is waiting. Now these two people connect to that server and the match happens there. Sometimes these fleets can be ephemeral if it's a small match which just ends in like a few minutes. Sometimes they want the matches to last as long as 2 hours. Some massive online games just want it to be persistent. And so there's a lot of flavors of this and a lot of complexity that comes into play in this architecture as well. And so one of the biggest things the minute you think about real-time multiplayer is netcode. Netcode suddenly starts coming up. Similar to how matchmaking becomes important, netcode starts coming into the foray here. And we are big fans of Mirror. For the Unity devs out here, Mirror is one of the libraries that is very popular and used by a lot of Unity devs. But there are a lot of other things like Photon, etc. that you all can use. And the best way to think about Mirror is it's an amazing software layer where you have device number 1 and player object number 1 on your screen in a 3D space in a game, and same thing with someone else. And this software layer is just making sure that the information about their position, etc., is transferring between devices so that I can see you on my screen. That's the best way to think about it at a high level. But here's Animesh, who's going to actually now dive deeper and talk to you a little bit about our mirror integration.
All right, so yeah, mirror, like I wouldn't even know where to start building a multiplayer game as a client dev with limited backend knowledge. Like I wouldn't even know how to sort of start that process. So now think of this, like if there is a game with 2 players in them, I need to mirror the positions of both of them on both the clients. So I need to do some networking, I need to pass this information, and it just creates this whole complexity around game development. But what I want to do is actually like make a game where people can play ping pong together or people can play cricket together. But that's my focus, right? So mirror kind of helps us do that. Like it gets us a lot of the heavy lifting is just done under the hood. So you can add a network behavior to a component, and that the position and the rotation and everything of that game object gets transported to all of the clients that are involved in the game, and then we'll see a little bit of that magic later on in the demo.
One thing. So mirror, you will still have to put in a relay server. Like it's not just transferring in a vacuum. Mirror connects to a relay server, and then all what Animesh said is essentially transferred between the people who are connected to it, and so they will go hand in hand. You will have a mirror hand in hand with a relay server, and that's actually the demo he's going to show, where we're going to tag in the Hermes, which is our relay server.
Right. So what we were able to do is the transport layer that you see in orange over there. That's the low-level networking library. That's where we were able to hook in the Snapser relay in there, and then all communication happens through that relay server. And well, how does the synchronization happen on the client side? We'll go through the code a little bit later on, but what mirror provides is it provides us synchronized variables. So if you change a variable on one client, it automatically gets updated on all the clients. You can have events. There's a concept of sync hooks. So whenever a variable changes, it also has a callback associated to it. So all the clients are, you can just have, let's imagine like a player where it's a battle royale and one player died, and whenever that player dies, the client changes its variable to is dead to true, and that gets transported to all the clients. So it just makes it very easy to do gameplay stuff with this. And but just variables aren't enough, so we can make we need remote action. So there are commands which happen only on the server. There is client RPCs, which are calls which happen only on the client. We can have target RPCs, which is only some clients need to do some work. A good example of target RPCs would be a chat. Like if there is a 2v2 match that is happening, and then the people on the same team need to talk to each other, but they don't want the other clients to know what they are talking about. So that's how you would leverage target RPCs into it. And then there's a list here of all the supported data types that can be passed through this, which mirror supports. And this is the network behavior I was talking about. So it kind of out of the box gives you a lot of callback functions. So when the server is started, you want to perform some actions. When the server stops, you want to perform some actions. So this usually is for handling the game flow. So if the server stops for some reason, you don't want to abandon the clients in some way. You want to maybe bring them back to the main menu in some way or the fashion. So all of this goodness just kind of comes out of the box for you, and it just makes the client dev's life significantly easier. So now let's do again, like the similar setup as we did before. Now we want to add a relay server to this, which we call Hermes. And then we also need matchmaking, because how else would the match be made, right? Oh, I already had that integrated. Okay, so matchmaking, so that's another thing. So now matchmaking, the relay server has a dependency of matchmaking, so that one automatically got snapped as well. So now this is how our snap looks. This gives you like a snapshot of what your backend is, just in one screen. So let's continue with that. Let's snap it. Any questions about mirror, networking, multiplayers? Yep.
How does this relay service work? Is it WebSocket or WebSocket?
WebSockets. Yeah. This one we've done WebSockets. But mirror itself gives you like a bunch of options. So they have, so the transport layer that I was talking about earlier is where you decide how you want to do it. So the mirror gives you a bunch of options. We wanted to integrate our own relay, so we used WebSocket.
But if your question is coming more from like will more transports be available? Yes. Like again, it's very similar to the auth connector. We want to build TLS UDP based transport. So we're adding more transports, and then we'll give that as a configuration option for people to use different transports.
My question is on the matchmaking. So that is basically a logic that is decided based on the game, right? Like
Right.
which went to
Correct. Yeah.
match, so how can that be a plugin service?
Great question. And you'll actually see how, because matchmaking, the way we've done is, it's very similar. The thought that comes to your mind, think about leaderboards that you saw here. So we've built the logic, but we still give the power of coming up with our own algorithm via a UI tool. So Animesh is actually going to go to the matchmaking admin tool. He's going to come up with whatever matchmaking rule sets we want, and the matchmaking is going to adapt to that. And so even if you've only snapped in the functionality, it's useless till you go and add a match profile.
So now I'm gonna update the SDK again.
Amish, quick question. Are we going to show them the game first for some?
Yeah, let's do that.
Yeah.
Actually, let's show the game
I'll
first.
probably have to change the URL, right, to the new snap menu created.
Yeah, I'll just give you the. Just need the ID, right?
Kudo change karo.
Network manager. And then I'll just send you the URL. Yeah, I'm gonna have to update that too.
Okay, so for everyone here, what we're trying to do now is we've snapped our snap-in with all the things we need for unlocking multiplayer real time. He's downloading the SDK. I have Unity running here as well, and if we actually were able to pull off a live workshop, all of us would be playing this game. But we're going to build like a 2v2 experience here of red light, green light from Squid Games, and we'll see if this works. That's the only change, right?
Yeah. Okay, so now we will also change scenes and go to like a different scene I've created for, we call it Interstellar, where it's just red light, green light. Okay, so now in this scene, I will also have to update the snap-end URL. So we'll first play the game, and then I'll walk you guys through the structure of mirror networking and how relay server kind of works, and we'll kind of get into like the technical aspects of it and give you guys options to ask questions if any.
Okay, let's see if this works. We're going to do a live demo. You will have to create a match profile first.
Oh yeah, that's true. So again, similar to all the previous ones that we did, we want to create a matchmaking profile. This is where you govern.
Yeah, so to answer your question, this is exactly where we're going to do that. So while Animesh does that, let me explain a little bit, which is you can, on Snapser at least, you can have as many match profiles as possible. And so you go from top down because, you know, game designers usually will have way complex algorithms and they wanted like a fuzzy matchmaking thing happening. And so what you can do here on Snapser is you can tell Snapser, or the matchmaking snap, which is now yours, not even Snapser anymore, is the min and the max players that you want. So if you're just building like a FIFO-based game, you know, two people come in, let them just go in, you'll essentially not even add any rule set that you see right here. So you just put 2 there and hit save, and that's it. But if you want to add complex rule sets, you can then start adding more power or more control to be like, oh, you know what? I want people who have statistics similar to me to be considered first for matchmaking. Then who's in the same league as me in the leaderboard. So you have complete control to come up with whatever makes sense for your game, and then that's how the matchmaking snap will operate. But for our demo, since we're only 2 people playing here, we are just going to use FIFO, which is you can delete your rule set, and we'll just do 2v2, and this table at least can see what I'm doing here because we're going to play this game.
And then you guys will obviously see him on my screen.
Yeah. If this works, let's see.
It will work.
All right.
It will work.
Okay, let me start the game. Okay, I'm added my username. And so let's go slowly, Animesh. So what has happened here is we both have logged in. I have logged in. It worked for me. You want to just restart?
Yeah. I think it's just Unity.
Yeah, Unity crashed.
Unity being Unity.
Okay, there it is. Yeah. So we both are in. And what we've done is this again is a decision of the game maker. You want to lobby, you want to just straight away put people in. Again, we've just chosen to like almost create like a join match button. Only after that is where you're going to hit the matchmaking snap and create a ticket. Obviously, anyone who's used matchmaking, it's all about creating tickets, and then the matchmaker figures out the best tickets. So that's what is going to happen after we both click that. So let me hit join match.
Same.
And bam, there it is. So you guys can actually see my screen. Don't press anything, Animesh. I'll quickly explain. So we have a red light, green light, which is the bar you see on the right is like the Squid Games person. And the minute it turns green, you can move your spaceship. The minute it turns non-green, you should stop. And so now that it's green, Animesh, let's go. Let's see who wins.
Of course,
Oh,
I'm going to win.
There it is. I died.
So then that removed him from my client as well. It configured its position. We'll play again.
Yeah.
Just so that we can show the...
Go try to win it. And anyone who's here, you can see how he's moving on my screen without... Did he move?
I mean, I died on purpose. So.
Okay, let's do it again.
So we'll leave and then we'll join again.
Yeah, I'll join again. And now this time game on. If it works. Come on. I'll have to restart it. I think
it timed. I think it needs that first rule, I think. Timeout one.
Okay, I'm joining a match. Once you hit submit. Your Unity crash again?
No. I think it's the Wi-Fi is really slow.
Oh.
So it's taking a long time to connect to the relay server.
It worked for me pretty quick.
There
Okay,
you go.
join match. It's finding a match.
Same key. I think we need to reset again. Is it working?
Yeah, I'm waiting for you. Your Unity is crashed, I think.
No, this is just the callback. It's still just trying to connect to...
No, mine is connecting. I think it's your Unity. There it is, yeah.
It's extremely slow for some reason.
There it is, join match. Okay, so
There
we
we
both
go.
are playing now.
So now you guys can see
Okay,
Ajinkya
we're moving.
move as well.
I'm moving. Okay, I have to stop now. Go. I think the network is a little,
Yeah, there's more lag, there's more latency.
if you see my screen, there's a little bit of latency here.
Both of us.
There it
died.
is, yeah, so I win.
But anyways, this was probably, I want to say like 40 to 48 hours worth of my work. And if I didn't have Snapser or Hermes, this was easily like a team of engineers going back and forth, bugs, solving this. This is like at least 1 to 2 months of like a team of engineers. So that's the power of Snapser that we wanted to kind of showcase here.
And so so his question was about latency. I think like these guys could see my screen, there will still be latency, and I think that's where a lot of these netcode solutions come into play, right? So they have, they extrapolate and they kind of figure out where should the person be, etc. We have none of that, and I think there are software solutions to make that latency feel even lower. And people who've played Call of Duty here, I used to play a lot, live. You see people kind of staggering. That's nothing but the netcode kind of trying to compensate and figure out where they are. And so you will essentially, if you're building a serious game, not just the relay and mirror, you will probably even consider some kind of a library there.
Any questions about the network? Yep.
So what are the limitations do we have over here actually? For example, I developed a game business.
Yeah.
So my game got in concurrent users. So what is the limitations currently we have it actually? So is there any pricing plan or like?
Yeah. So right now we've, like I was saying, we've not really opened up Snapser for developers yet, and it's like we're only working with game studios. And what we in the near future we are going to open it up to developers. And so essentially, when it's a developer who's launching their game, we will essentially get a sense of their DAU and scale it for them, etc. But our whole intention is to give the game studios more power, and so they will have the knobs to figure out how much they want to scale, etc. For usual devs, if you are a breakaway hit just suddenly overnight or something, we use Kubernetes. And so we have essentially scaling requirements based on memory, based on CPU that we've put in already. And so as people come in, you will see that automatically scale. So we try to take away the burden from devs and game studios to not really worry about that, because we can horizontally scale and add more hardware under the hood.
Just before the questions, I did skip the mirror portion of it a little bit. Are you guys interested in knowing that, or do you just want to continue with the questions? I just want to get that. Like, I just kind of like skimmed past it. But I'll just like quickly show you how you can, how basically we can use mirror. So mirror kind of gives you these components. So it has the network identity. This is basically, think of it like a unique code for each client and the objects on the client, and that gets shared between all of them. Network transform is, so if you guys know transform is just like position, rotation, scale. Network is how it gets synchronized amongst all of them, or amongst all the clients. And yeah, that's pretty much it. Like, those are the two components that you need to have like a synchronized game object on one client, and then it goes everywhere. So it's literally just as simple as that.
I'll add one thing. So for those who've used Mirror before, Mirror like came out of the whole Unity netcode project, and Unity kind of just gave it away, and then the Mirror community built it. And so it was heavily relying on the Unity relay. We've actually written our own transport, and which is the reason why it works with Hermes. And so we're supporting Mirror as a first-class citizen. So you can essentially just put Hermes in, put in that cluster URL, and things start working. You don't even have to worry about it. But for anyone using vanilla Mirror, it's not like it just works with any system. You will have to write your own transport.
Right. And then the interpolation that you were talking about, like the latency. So Mirror kind of gives you a little bit of that as well.
Control. Yep.
A little bit of control, so it does like the catch up, so it'll smooth out things for you. So that's just something that game devs can go and then geek out.
Play with those variables.
Yeah, and then or write your own. And this is also the one of the main components is the network manager, and this is where this is run only on the server, and this is how it governs. Like, all right, this client has joined the server. This client has joined the server. Tell him this, tell him that. So this is sort of like the brains of like the whole thing, the brains of the operation. Hermes transport is what we were talking about, how we wrote like a transport layer with WebSockets, and this is how information gets actually transported. And then we have the WebSocket connection manager, which manages the WebSocket. Like, if it closes, it sends out like a callback, and then you can manage your UI accordingly. So yeah, that was like a quick mirror run through which I just.
Yeah, I think we'll end up sharing the game. So more questions. Even if you all go home, look at the repo and ask us questions on Discord. But yeah, let's take questions. You had a question? You want to pass a mic to him?
I have
Oh, sorry. I asked. Yeah.
mostly the servers they suffer while low internet issues and mass footfalls. So like how Snapser is more better than all other servers, like some unique thing.
I mean, see, we're not claiming to be that we're extremely unique than anyone else. I think what we're claiming though is that we're going to make your life way easier than some of the other things. So technically speaking, you might be at par in terms of what you get out of a relay, but the ability to just snap things and start and bring in exactly the things you want, that's essentially how we're building Snapser, like a Lego building block. And so fundamentally, that's how we're different than some of the other people.
Also, just to add to that, the latency portion and all of that, that falls on the mirror side of things. Snapser is more of like the backend that supports all
Correct.
of this.
Yep.
But mirror is where you would want to handle the latency. If someone is really slow, then kicking them out. All of that comes on like the client side. There's not a lot that Snapser can do about it, but to support all of that.
Correct. So we handle the relay part and we handle the scaling, right? So now it was just 2 people, but if we all were playing, you all had your laptops, you could all be playing it and it could just will magically scale, adapt to that, create ephemeral matches, break them down so that you're not wasting money. And usually mirror that is used by Unity devs, they use like the Unity relay server again. And so y'all are incurring that cost. So it's kind of the same thing, but we've just made it easier within Snapser.
Yeah, my question was, what is the tick rate at which both the different devices send their updates to the server? For example, if there are 2 devices with different frame rates, for example, for 144 Hertz and 60 Hertz, so how does different rates of incoming messages, how does that
Yeah, great question.
handle it?
That's actually what mirror takes care of. So that's the layer that we don't, it's more of a black box and you'll get controls like that to figure out what's the right cadence to send it. And so I think if you want to deep dive on mirror, let's chat later on and talk more. In terms of Snapser, that's not something that we handle.
Is there a way to control that? How often does the update goes through the
Yes,
server?
yes, yeah, through the one of the components right there.
There are multiple actually. So there's like a global send rate. This is what governs, and this takes. Think of it just like a machine. Like you just have to move knobs just to get everything right. But this is like the global one. Send rate, and then each network behavior also has its own
On the game object.
On the game object also has its own send rate. So these in combination with each other is how you kind of govern how frequently you need to send information out.
So I had another question on the tick rate of the relay server actually. What tick rate does it operate at? And secondly, can you change that tick rate?
Great question. And you're probably a user of Nakama or Heroic Labs, which is where like this is coming from. Yes, we right now do not support tick rate, but that's the enhancement to the relay server. We are a full-on vanilla relay server right now. But the next step of Hermes is adding the tick rate where we allow people to bring in their own code and then tag it into Hermes and then start using it. And that's where we'll expose that information. In full transparency, we don't have that at the moment.
Also, would you be expanding into subtick? So
maybe in the future. Right now, I think we want to get it to par with the Nakama product, for example, and then take it from there.
So, my question is going to be very simple. So basically, you said there will always be bad actors. So from Hermes' point of view, is there a way to ban someone from matchmaking from Snapser backend?
Yeah. So if you see a lot of these snaps, we have like a social graph snap, we have an auth snap. So we give the power to a game studio to be like, I want to ban this user. And the minute the user is banned, essentially calls to the gateway will be blocked for the user. And so that is how they will never be part of the polluted matchmaking. They won't be even able to create a ticket in the matchmaking snap. And so that's how a game can be protected. You had a question.
He had a question.
Yeah. Okay.
So I saw some options for different game engines. What about custom game engines and implementation?
Sorry, you mean the SDK? Or?
Yeah.
All right. So what we have here is we support these so far, but if there's a custom engine, you're essentially using some kind of an underlying programming language. We actually support plenty of programming
Probably
language.
C++, like most of them.
Yes,
Right.
so like we already have Cocos or any C++ package that you can pick up, and that'll essentially work for any custom game.
So this says Unity C# because Unity is the biggest game engine, but it could be C# anything.
Yes.
Like it doesn't really matter.
And
It's
I mean-
more for like
But,
ease of
what
understanding.
about if the game engine is architectured in like in a certain way, like for example, like different implementation of ECS or something?
Yeah, good question. And I think again, like our whole fundamental philosophy is like slowly keep adding these building blocks, and even building blocks in terms of functionality or tooling or availability of these things. And so we work with the game studio. If they're working on a custom engine, we will build that component for them, and then they will see a drop down where they can pick their engine and download the SDK. So yeah.
Thank you.
I'll give you a quick example of how languages, platforms, and their eventual dependencies make a big difference. So C# has certain dependencies like Newtonsoft, like JSON, like for the serialization, deserialization. But if you go to Roblox, everything is just JSON, so everything just works. Like you don't get access to the networking side of things, but it just works. So if there's like a specific game engine, we'll have to address what dependencies that specific game engine has, and then that is the supporting bit. But the SDK itself is ready to go. It's just like the bridge that you'll have to build in the middle. That's just something which is of an unknown.
Like visualize it as like Lego building blocks. We've built it for like almost all possible languages you can think of. And then the minute there's anything custom or Unity, we add a layer of top to massage it in a way, and then throw out the zip file. So it's pretty much that. Someone else had a question. Yeah.
Yeah, so this was mirroring, right? So do Snapster also provide a turn-based multiplayer service or something?
Sorry, come again?
Like a turn-based multiplayer game.
So that's
A real-time.
Yeah. So I mean,
Yeah.
so yeah. So think of Snapster as like the funnel, which is enabling the clients to do what they want. So that lies more on the client side of how you would do it turn-based.
yeah, and I'll ask you. Answer it very easily. So that's exactly as you said, completely up to a client. There are one or two ways you can do it, right? One is words with friends, completely asynchronous. I play a move, and you can then play a move 2 days later. That you don't even need a Hermes or a relay. Like people just essentially create like game objects and blobs and then store it and then do that, right? Sometimes it's I play a move and then I wait, but I'm looking at your move. It's more of a live and real-time thing. And that moment you'll use Hermes. So that's the best part. We have like other snaps like storage, etc. that completely you can use to make a turn-based game possible. But the minute you have a real-time thing, we have Hermes to help you out with it.
Got it.
Yeah. Any other questions?
Questions?
I think it's giving the mic. Yeah.
So sometimes the problem we run into is if there are parallel connections coming back to authorization, if there are parallel connections, there's a conflict or, let's say the progress or something like, so is that something configurable, whether we can have, multiple devices connecting to the same authorization, same user? Or
Yeah, we support parallelism absolutely. I think to us, every call is almost stateless and independent. And so you can use the same token, and the same user can have like 10 iPads with their 10 fingers playing the game. We don't care. Yes, if you're using the underlying same blob to store that, you will have a conflict, and then that's the decision point where the game maker has to figure that part out. But as far as Snapster is concerned, that's not really an issue.
Okay, that's something the game has to figure out how to.
That's correct. Yeah.
Right.
And the other thing is.
But I'll add one thing. Unlike some other solutions, we do provide optimistic concurrency control. So what that means is that usually the way it works is, let's take Farmville as an example, right? So I have my farm, and I'm a client, and I updated and I bought a cow in Farmville. And now I want to store the state of my new farm with a cow in it. I essentially have to pass in a cache, which is check and set, and only then am I allowed to do that. So that is one way that you can protect. If you're a multi-device and the same actor is kind of playing on both, you will always ask the actor, hey, seems like there's a conflict, you're on some old cache number, you pick which is the state that you want. That's exactly how we used to do it on Farmville. We used to throw that pop-up saying, seems like you have two states, pick the state, then that becomes the state that gets pushed to the cloud, and then you start progressing.
I was about to ask about the server SDKs, but I guess it's already there. So.
Sorry?
The server SDKs, because most games will be server authoritative, right?
Yep.
Instead of client. So I was just about to ask that, but I noticed there's server SDKs as well.
Yes,
Yeah,
there are
there's
server
server,
SDKs, and I think one of Snapser's superpower. Again, I think let's talk about that after the session. We actually provide something called as bring your own Snap, and that's the power of Snap. So you can actually write your own microservice, monolith, etc. And unlike other people making you push it on like a Lambda, which has a cold start problem and whatnot, this actually gets added into your own cluster. So you actually have a complete experience where there's no latency issues because it's in the same cluster for your game. And that's why if you go to snapster.com, we like pride ourselves being the first customizable backend platform. Acha. Any other questions, concerns, comments?
So the game repo is going to be public, so you guys can go, like the ideal, the way we had imagined is like everyone's just going to like write code together, but then obviously like I think that was too ambitious with the Wi-Fi and everything. But yeah, if you guys want to go and do whatever you want with this later on, I think you guys have the freedom to.
So a few things. Obviously, it takes guts to bear with a boring, dry presentation like this. So as a thank you, we've bought some swag for you folks. There's Snapster t-shirts. Just pick up your size, and thank you for listening to us. There are also laptop stickers right here. But for people who want to hang back and just chat with us about anything, we will be happy to. We're also opening up like a sheet for devs, any like indie devs, game devs here who are interested in just giving early access, like being part of an early access program for devs. We're going to start a sign up sheet, and so we'd love to get your emails.
Thank you guys.
I know this was for 4:45, but we're ending half an hour early. Thank you so much, and have a good IGDC.